In this lecture, we are going to discuss about the polar representation of complex number. If z is equal to x plus high y, x plus high y is my complex number, then draw the polar representation of the complex number. This is pxy. If we draw a perpendicular from b to x-axis, this is m, this is o, this is my real axis, this is imaginary axis, this is the angle theta, and this is the radius vector r. Then in triangle OMP, cos theta is my OM by OP, that is equal to this portion is my y and this portion is my x, as this p coordinate of p is xy, so this portion is x, this portion is y, so this is x by r. This implies your x is equal to r cos theta, and sin theta is equal to pm OP, that is y by r. This implies y equal to r sin theta. So that x square plus y square is equal to r square cos square theta plus y square is my this one, y square is this one, r square sin square theta. So take r square common, this is cos square theta plus sin square theta. We know value of this identity is 1, so this is r square. This implies r is my root over x square plus y square. Okay. Next, tan theta will be my sin theta by cos theta. From here, sin theta is my y by r, and from here cos theta is my x by r. This implies y by x equal to tan theta. This implies theta is equal to tan inverse y by x. Therefore, putting the value of this in x equal to r cos theta and y equal to r sin theta here, in the next slide we will get z equal to r cos theta. In place of x we can put r cos theta. In place of y we are going to put r sin theta. We will put r equal to sin theta. Now take r common, this is cos theta plus I sin theta. This is the required polar representation of the complex number. This is also known as modulus-argument representation of the complex number, where r is root over x square plus y square, and theta is my tan inverse y by x, and this is sometimes also known as modulus-argument form of complex number, okay. Theta is known as argument of the complex number, or amplitude of the complex number, denoted by arc z or amplitude of z. the value of theta, the value of argument, the value of the argument in the interval theta lies between minus pi to pi is known as principal value. The length of argument is 2 pi. Here at this point theta is 0, goes up to here. At this point theta is my pi by 2. Again here, come here, at this point theta is my pi, then again here it will be 3 pi by 2, then again here it is 2 pi. Sometimes 0 is equal to my minus pi. Okay, so this is the range, this semi-circle version. The general value of the argument is the general value of the argument is 2n pi. Since the length is 2 pi, we know theta is periodic with 2 pi, so this is 2n pi plus theta, where n is my any integer, The argument of 0 complex number, argument of complex number 0 is undefined, as 0 cannot be uniquely expressed as r cos theta plus I sin theta. Okay, there is no unique expression for 0. We can take this 0, so there is no unique expression, so argument of 0 is undefined. Next is properties of a complex number, properties of argument, not complex number, properties of argument. Number 1, arg of z1 z2 is equal to arg of z1 plus arg of z2. Number 2, arg of z1 by z2 is equal to arg of z1 minus arg of z2. Next, we are going to solve one example. So that arg of z plus arg of z conjugate is equal to 2n pi, where n is any integer, Answer. Let z be the complex number x plus I y, so that then z conjugate will be x minus I y, we know that arc of z plus arc of z conjugate will be my by using properties discussed here. This property number 1. By using this property, arc of z pro, if you product this, you will get this one. Arc of x square plus y square, as this here this x and y are real, okay, this x and y are real, so this portion is real, that means it lies in x-axis, so arc is 0. Whenever it lies in x-axis, arc is 0, since x square plus y square is real, so principal value of arc x square plus y square is 0, and general value is 2m. Therefore, arc z plus arc z bar is my 2m answer. Therefore, arc z plus arc z bar is equal to 2m, where n is any integer, where n is any integer. With that, I would like to conclude. Remaining will be in the next lecture.